This is a small British company who built this. It was a company called Levell, um, and they made a number of things. They used to make sort of budget test equipment. They used to make decade boxes, various signal generators, frequency counters. You know, the basic stuff for um, entry level electronics, really. This is one of the pieces of kit I've got of theirs, and this is the AC microvoltmeter, and it's a TM3B. There's a number of different ranges models of this about. This is one of the later guises, um, and this basically is the equivalent to a VTVM. It's a very high impedance front end. It will measure voltages down to 50 microvolts all the way up to 500 volts. And it also has bandpass on it, so you can filter out noise and you can narrow down the bandwidth to what you want. It's a pretty basic construction. It works on a PP9 battery, which is the large type batteries used in the Hacker radios. It's the next size up from this battery here, actually. I've had this a couple of years. It doesn't get used a lot, but I've just been doing some calibrations on just checking some of my equipment. I've just calibrated the Wayne Kerr, which is now absolutely spot on, actually. And I'll probably do another video on that to show you what I've done on that. But this meter is it's a lovely thing, actually. It's very basically built, and it's got the typical sort of British styled tin case and sort of, you know, sort of slightly homemade look about it. I'll take the back off so you can have a look inside. There's not a lot to it. Held on with 3 screws. Obviously lost one of the screws. Now you can see inside, actually, because the current consumption is so low, I've actually modified it to take a PP3 battery. The PP3 battery will last absolutely fine on that. So basically, that's the insides. There's the all the part of the sort of amplifier with the transistors here for amplification, a couple of calibration points. It has a couple of variable capacitors, I think, on the back for compensating for frequency response. But obviously, that's probably not that important, really. All I really ever use this for is an indication of peaking an IF strip or something like that. It doesn't get used for a lot else. But I'll just quickly show you its response, what its response is like. I just put one screw on for the time being. So I'll connect it up to my a Philips signal generator here, and now I'll plug into the front. And we're running at 1 kilohertz at the moment. And I'll just set an amplitude, and you'll see on the edge of the meter at the top here, we'll set to 2.5 volts, as close as I can. Control's very jumpy. So 2.499. So we'll turn the meter on. Now it's got quite a while. It takes a little while to settle this meter. And what I have actually done on this meter, because I've seen it before, they do have protection on the front on these meter movements. But the trouble is, if it swings quickly to the end, it can bend the needle. So what I've done is I've put a heavy capacitance across this meter, so the response is very slow. But let's put it to the 5 volt range, and then you just got to wait for it to stabilize. And obviously the 5 volt range is this bottom scale here, so we're looking for half deflection on the meter. Just wait for it to settle. There we go. And you'll see there, get the parallax correct, it should be smack on 2.5 volts. You know, that's excellent. So let's move it up to a different, let's try it at a higher frequency. So we'll try 1 kilohertz. Let's try 100 hertz and see what that's like. Just check our amplitude again. 2.496 still. Exactly the same. So that its frequency response is pretty good up to that point. Let's try it at, okay, just under 100 kilohertz. Let's check our amplitude. Let's set that to 2.5 volts again. And okay, it's slightly down, very slightly down on the high frequency response. We see we're using the wide bandwidth, but then again we've got to take into account that I don't know what the frequency response of the meter is. But there you can see, I mean, you know, I'm never going to use it that sort of frequency anyway. This is only going to be connected to an audio connection with a loudspeaker or anything. Let's try it at a very low frequency. Let's try it at 10 hertz. And amplitude. Obviously, it's a little bit harder to get this right because we're moving into the DC realms of frequency here. It's almost sort of very low frequencies. It's at 2.5 volts. And you can see they're absolutely fine on 8 volts again. So they're a nice little meter, and as I say, it's got a good ability to filter out to a high frequency. So if I set that to 100 to 350 hertz, if I increase that to 1 kilohertz again, circa frequency 1 kilohertz, you see the roll off has taken into effect because the pass band is blocking anything above 350 hertz. So that's a nice little meter. You can pick them up on eBay for sort of like 15-20 quid actually. They're not hugely expensive. And I've seen quite a few of them about. And as I say, this is the later range. I've got another one somewhere, I don't know where it is. I know it's buried in the workshop somewhere. It's behind here, I think. Let me just dig it out. Got so much junk lying around, I don't even know where anything is anymore. But there's another one, and it's much earlier. It uses germanium transistors. I don't know where it is at the moment. It's buried under this lot somewhere. And that's nice as well. But this has got a better range of selection range, so you can guarantee that you'll more or less get your meter exactly where you want it in the scale, because you've got such a fine vernier of different ranges on the output or the meter selection. Whereas the other one has far fewer ranges and hasn't got such a good and precise meter. But yeah, that's the AC Levell TM3B. A great replacement for a vacuum tube voltmeter. Of course, and the other thing is it's totally isolated. There's no connection to the mains. You can just plonk it on your bench and connect it up, and you've got no worries about earth faults or isolation transformers. If you're connecting this up, you're pretty safe. Obviously, I wouldn't recommend running it on the outputs of a valve audio amplifier unless you go through the transformer, the output transformer, because you don't really want sort of 300 volts connected to this. I don't know how good the isolation of this instrument is. You could find that the whole thing becomes live, and that would be quite unpleasant. But yeah, you know, for within reason, for checking audio output and peaking IF strips, it's absolutely great. Anyway, thanks very much for watching.